let me introduce the next topic and speakers. So we have the honor of having our KDDI customer, let me get this right, Mr. Nakamatsu-san, and a good friend of mine, Hiro, who is one of our rock star NSO developers.
Thank you.
From our CX team. And they're going to talk about the KDDI use case with digital twin, which is a big topic in the industry these days about digital twin. So I'm really excited to hear what you guys have done here. So thank you.
All right, thank you, John. All right, so thank you everyone for attending. So I'm Takahashi from CX Japan. So when we talk about Japan, there are so many famous things. Anyone, any ideas? You know, yeah, sushi, yes, sushi, and sake, or anime, what? Godzilla, yeah, perfect, thank you, right? But actually, there's one another thing Japan is famous for. That is, Japan is fast-paced aging country. So what does that mean? That means we are losing a lot of good engineers because they are retiring, and that's happening in the network industry as well. So to cope with that problem, what we need is to automate network operations. And here, Mr. Nakamatsu from KDDI is leveraging network automation to cope with that kind of problem. So without further ado, let me introduce Mr. Nakamatsu from KDDI.
Thank you, Hiro-san. Good afternoon, everyone. Thank you very much for joining our session today. My name is Takumi Nakamatsu, and I'm a network architect at KDDI. Over the next 20 minutes, we will share our vision and initiatives for autonomous network at KDDI. First, let me briefly introduce KDDI. KDDI is a leading telecom operator in Japan, serving around 31 million mobile subscribers. Internationally, our subsidiary operates 45 data center sites under the Telehouse brand, and we provide over 15 million IoT connections globally. My role at KDDI involves designing a carrier-grade IP/MPLS backbone networks and the leading automation initiative. Last year, I was honored with Cisco's Outstanding Automation Awards. By the way, that me in the photo on the right, looking just as nervous I feel today. So anyway, I'd like to share the part of this journey and our future goals. Let's begin by the understanding why network automation and autonomy are becoming essential. There are three major factors influence the telecom landscape in Japan. The rising demand for mission-critical connectivity, driven by explosive growth in IoT and AI. Intense pricing competition characterized by the price cut, service diversification, and new entrants from different industries. Significant demographic challenges. Japan faces a declining and aging population, resulting in fewer users and critical shortage of skilled network engineers. Specifically, the demographic issue is critical. With fewer skilled engineers available, we must automate manual tasks and pass genuine network autonomy to maintain service quality. Let's look closely at these demographic realities. The working age population will drop from 59% in 2020 to 51% by 2050. Already, 29% of the Japanese population is aged over 65, the highest percentage globally. Just 2.1% Japan's workforce are IT engineers, ranking 37th among the developed nations. Accordingly, Japan's Ministry of the Economy, Trade and Industry, METI, there will be a shortage of approximately 450,000 IT professionals by the 2030. Simply put, we must achieve more with fewer people. That's why autonomous network is crucial. Now, let's define our objectives for autonomous networks. We identified the three key outcomes: cost efficiency, reduce OpEx and CapEx, through automation and AI-driven optimization of network design operations, service agility, shorten the time to market from weeks to days using CI/CD, network resilience, implementing the self-healing and predictive monitoring to reduce the MTTR. To achieve the outcome, we use TM Forum's autonomous network readiness model as a reference. Currently, KDDI is at level 2. Our goal to reach level 3 by 2027 to keep pace with the global tier 1 operator, and level 1 or level 4 or higher by 2030. Next, let's discuss the key technological enablers that will help us reach these goals. We believe three key enablers are essential. Digital twin, a high-fidelity simulation environment enabling safety testing and rapid CI/CD, data intelligence and automation, utilizing the telemetry data to enable closed-loop automated actions, and agentic AI, intelligent agents that transform insight into autonomous actions. We believe these three are the keys to reaching the level 4 and beyond. Deploying the agentic AI directly onto our production network carries risks, which is why we use digital twins as a protective layer. This twin-driven approach ensures the safe and continuous improvements through the 3 steps: safety validation, continuous learning, controlled rollout. The benefits of this method include risk isolation, rich data insights, comprehensive metrics, and continuous enhancement. Simply put, a digital twin is our sandbox for safety developing the autonomous networks. Let's look at the specific use case we are working on. Our use case demonstrates autonomous network operations using agentic AI. Operator can issue the command in the simple and natural language, like a configure BGP between Tokyo and Osaka. A generative AI agent interprets this request and executes the necessary operation, whether CLI or API-based. Accuracy is ensured by a multi-agent approach, cross-checking intent, network topology, and policy compliance. We aim to replace manual operation with agentic AI, of freeing our engineers to focus on innovation. We have implemented the 5 specialized agent types: orchestration agent, receive the user intent and coordinate tasks across other agents; device agent, discover routers and share their device-specific details; policy agent, identify and provide the correct rule sets for network configurations; configuration agent, store the procedure data and instruct the orchestrator to execute the procedures. The last, the monitoring agent, continuously observe the network links and report anomalies. Each agent maintains its own dedicated knowledge base, illustrated here in blue. Let's see how agentic AI coordinates these agents in a practical example a BGP configuration between Tokyo and Osaka. First, the orchestration agent requests the device agent to raise relevant routers. Next, it consults the policy agent to retrieve the appropriate rule sets. Then, the configuration agent fetches the request procedure and applies the configuration. So finally, the monitoring agent verifies that there are no anomalies. We utilize the Cisco NSO to achieve the API-driven intent-based network. More detailed information will be presented in the next slide by Hirotsugu Takahashi. Hiro-san, please take it from here.
Sure. Thank you, Mr. Nakamatsu. Okay, so now we know AI agent is a key, but integrating AI agent with network, hasn't been happened so fast. Why? Because integrating AI agent with network is not easy. Just typing AI agent to do that stuff. To make configuration, that doesn't happen. So usually we have something in between like this. So most of the time we use some kind of code, but that is very that is very hard. So what we now NSO Cisco NSO comes in handy. Once we put Cisco NSO here on top of network, then we can enable API for network. So once that happens, what we need to do is to just use API. So we don't need to write any code since we can use no code, low code solution, that kind of stuff. So by using NSO, we can enable API for network. That helps us a lot to accelerate this kind of deployment. And once we have enabled API for network, what we need to do is to just input network intent. So what is intent? I don't think I need to explain here, in this audience, but the intent is kind of parameter. Like when you set up a kind of VPN, just set up VPN from router A to B by using ID 123, and that is actually AI agent is very good at. How? Maybe some of you know the way called future learning. So future learning is the way to give LLMI some example, like if I type A, just give me this. If I type A, just give me this. Then how about this? Doing that way is called future learning. So by doing this future learning, we can even get this kind of JSON format by using LLM AI agent. So once we get this kind of body, all we need to do is just pass this body through our RESTconf. Thank you to Cisco NSO. But to do this, we need a service package. So when I'm working with Mr. Nakamatsu, we figure out another way, that is pass CLI configuration through RESTconf. So passing CLI configuration through RESTconf API sounds silly, right? But this comes in handy, especially when we are testing. And to do that, I built a custom package, and this is one sample code using Python. So here I have NSO class, and in this NSO instance, I'm calling this RESTconf path, and here is run CLI package. This is a custom package I built. And if anyone interested in it, this package is available on the GitHub. But LLMI is good at generating CLI configuration, and once we get the CLI through AI agent, just pass the configuration like this using RESTconf API. Then we can do a dry run and commit. That's that's the way we integrate agent with network. So let's see the demo, how it works. So Mr. Nakamatsu, back to you again.
Thank you, Hiro-san. Now let's watch the brief demo video. The poll appeared, and we type hello, and it replied, hello, what would you like to talk about today? We request that please sell out the BGP Tokyo and Osaka. The orchestration agent to query the device agent, which returns the host name. The next it queried the policy agent, which responds the policy Tokyo DL2. The orchestration instructs the configuration to apply the Tokyo DL2 policy on the Tokyo router and the Osaka router. The configuration agent confirms completion. We ask, tell me the BGP status on the Tokyo router. The monitoring agent will return the detailed status. We ask, where is the Tokyo router located? The device agent provide the location information. And we finish, oh, thank you. And the agent replied, you're welcome. Another challenge, we're facing the long tail problem in network operations. At Dev Day US 2024, Mr. Habirantik introduced this, which strongly resonated with us, so we'd like to highlight again here today. Current tool effectively handle common or frequent incidents, the left side of the curve. However, rarely frequent incidents, the long tail caused on the right, still require the expert human intervention. Our objective is to automate resolution for their complex long-tail issues. One promising approach we are exploring the multi-agent listening loop. When a user reports something wrong, please investigate. It triggers a listening loop. Step 1, define initial premises and rules. Step 2, agent collaboratively discuss and debate the potential hypothesis. Step 3, a moderator synthesizes the agent viewpoints. And step 4, collect further evidence through the telemetry or external data and iterate the discussion. The loop continues until the consensus is reached, after which the orchestrator executes the necessary fix. Now let's watch another short of them video to see this process in action. Traffic can pass between the Tokyo router and the Osaka router. We've been asked to find out why. Open the minute file and list the route details and these current status. The demo features Alice, Bob, and Cherry. Alice suggests checking the BGP status. Bob shows the exact commands to pull data. Cherry's add the comments to support the Bob. They collect all the required information. Nothing wrong with the human profile, so we sign off first. Then they learn the log question tool and check the live devices. As log come in, there's 3 agents talk on screen. You can watch their reasoning in the real time. This is, as we say, external AI. Once we spot the likely root cause, the discussion ends. Finally, they present a conclusion to us. In conclusion, here are 3 key takeaways from our session. Digital twin, a realistic sandbox environment to safety mitigate risks and accelerate learning, including the handling complex real long-tail scenarios. Data intelligence and automation, closed-loop automation enabled by telemetry data and intent-based API-driven orchestration. Agentic AI, autonomously performs tasks traditionally executed manually, delivering the capability and performance beyond the conversational operation. Together, these initiatives are guiding us along the path toward autonomous networks. We look forward to sharing more of this journey with you. Thank you very much for your attention. Thank you.
Thank you.
Am I on? Excellent. Thank you very much.
Thank you.
The digital twin is you hear about it a lot in the industry. It's amazing you guys built this, with CX and by yourself. I guess I'd like to ask, if anyone thinks we should put a digital twin feature or capability into our product as a standard solution, please reach out to us, reach out to the product management team outside. So let's quickly go through some questions. Okay, anonymous. What is the single biggest challenge KDDI faces in reaching your level 3 goals by 2027?
Our biggest challenge is data. Is if the digital twin differ from the live network or is even fewer minutes behind it, the AI can make a long decision. So the task to keep every configuration topology map and or telemetry value fully up to date all the time.
Okay. There were 5 agents in your slides. Do you need to maintain all the agents regularly or just a specific one?
We maintain all 5 agents, but each one need to update on the different schedule. In practice, most of the ongoing work is updating the knowledge bases rather than modifying the agent code itself.
Okay. What accuracy and refresh rate do you require for the digital twin? That's a great question.
Oh, good question. Regarding the refresh frequency, it depends on the objective goals. For capacity planning, frequent updates are not necessary. And in network operation, the shorter the interval, the better. Accuracy is harder. Achieving the zero topology discrepancies is essential.
Okay. What platform or technology have you used for the digital twin?
I'm running the container-based loader, that's like the XRD. And we need some physical environment, so we use the same router in the running networks.
Okay. So the virtual XRD.
Yes.
But if there's a feature that doesn't run in the container, then you need a physical device. Okay, excellent. Okay, so I just want to thank you again. KDDI has been a tremendous customer for us, and we really appreciate your partnership. Thank you.
Thank you.
Thank you.
Thank you, John.